I'm solving section 26, problem number 41. We're given here, we have 3 points with their corresponding charges, labeled A, B, and C. We've got the charges written next to them. And we're given that the distances between A and B is 3 centimeters, and between B and C is 4 centimeters. You can use the 3, 4, 5 rule for right triangles to find that this distance is then 5 centimeters. And I've labeled these equal angles alpha. We'll use those later on. What we're doing in this problem is finding the net forces from B and C on A. We're finding the vector of the net forces on that, and that'll be using Coulomb's law, which I've written up here in the corner. The first part of this problem is to find the force between A and B. So I'll write out the formula for this. Force between A and B is equal to that K coefficient 9 times 10 to the 9th. Times, we'll use the absolute values of the charges. It'll be 5.0 times 10 to the negative 9th coulombs, and 5.0 times 10 to the negative 9th coulombs over the distance, which in meters is 0.03 squared. Put that in your calculator, you'll come out with 2.5 times 10 to the negative 4th newtons. And we can see, because this is a positive charge and a negative charge, they'll have an attractive force, so it'll be perfectly in a positive x direction. So we can just change this into a vector by giving it the I hat at the end of that. I'm going to erase this, but we'll use that later on. Next, we'll find the vector of the force between A and C. Once again, we'll use Coulomb's law. That's 9 times 10 to the 9th. Absolute values is 5.0 times 10 to the negative 9th coulombs, and 10 times 10 to the negative 9th coulombs over, in this case, 0.05 meters squared. From your calculator, you can get that this is 1.8 times 10 to the negative 4th newtons, and we can see that because these are both positive, the force will be away from C in downward to the left direction like this. We'll find that angle using some trigonometry here. That angle alpha, the tangent of that angle alpha, is equal to 4 over 3. So we can say that alpha is equal to the inverse tangent, or arctangent, of 4/3, which comes out to about 53 degrees. We'll use that angle in finding the x and y components of our vector so that we can add it to our first vector that we have found. So when we can just do this all in one step here. The net sum of the forces on A are equal to 2.5. This is our first vector, 2.5 times 10 to the negative 4th newtons in a positive I hat direction, and then minus, because it's in the negative direction, 1.8 times 10 to the negative 4th newtons times, for this, the cosine of 53 degrees in the I hat direction, minus the 1.8 times 10 to the negative 4th newtons in the j hat direction, sorry. Add all this together, you come out with 1.4 times 10 to the negative 4th newtons in the I hat direction, minus 1.4 times 10 to the negative 4th newtons in the j hat direction. And so we can see from this, because they're equal distance in the positive x direction and then in the negative y direction, this will be at 45 degrees below the positive x-axis. So we'll just find the magnitude of this because it asks us to put this in magnitude and angle. So we'll just use, I'll keep those numbers down at the bottom there. We'll use the Pythagorean theorem to find that the magnitude of that will be 1.4 times 10 to the negative 4th squared plus, again, 1.4 times 10 to the negative fourth squared. All of that, take the square root, you'd come out with 2.0 times 10 to the negative fourth newtons, and that's at that negative 45 degrees, or 45 degrees below the positive x-axis. And this is our final answer, solution to this problem. Put a box around it, and we have completed section 26, problem 41.